Well, welcome back to Chemistry Tutorials with Mr. Doro. Today we're going to be talking about molecular structures, and I want you to be able to complete electron dot structures for covalent compounds by the time we're done. A couple of things we got to know before we get started. These dot structures that we're going to be talking about are for covalent compounds only. We already talked about ionic compounds, how they exchange electrons, but this is for sharing electrons in the covalent compounds, and so we can only do them for the covalent. Each element has to have a full octet in order to be stable. Full octet, remember, means 8 valence electrons around it. That's what the octet means, except for hydrogen. Hydrogen is stable when it has 2 valence electrons around it, and that's really the only element that we'll be talking about with 2 valence electrons. Unfortunately, there's a lot of notes you have to write down for the rules for dot structures, and really they are critically important. I have them written down, and I'm expecting you to write them down so that when we go through some problems, you can go back through and you're going to see that if we follow each step, we just can't go wrong. The problem is students several times don't follow each step, and they do go wrong. But write these down, pause this right now, and then we'll go through each step. Okay, did you really pause it and write it down? If not, then you need to stop it and do it right now. Even though these steps might not make sense to you as you're writing them down, you might say, I'm confused already. That's okay. We're going to work our way through it. Have the steps written down so that we can go through them. Otherwise, you're going to be in bad shape. Okay, there's still one more step on the next screen too, so pause it right now. Go on. And here's that last step. It's a step that students several times forget to do and ends up getting them in a little bit of trouble, but there are some terms in here that we don't know yet, double bond, triple bond, but stop this and write this step down. This is almost all the writing you have to do. You just have to do some practice problems after this, so it won't be too bad. Okay, so we're going to start right out with this, going right through the steps. You should have out your periodic table. You should have those notes that with the steps right in front of you, and we're going to go through each step together to make sure that we can follow along. This is our compound that we have. It is CH3I, and the first thing that we have to do is count all the valence electrons. So looking at our periodic table, we can see that carbon is in group 14, and it has 4 valence electrons. Hydrogen is in group 1, and it has 1 valence electron, but there are 3 of them because that little subscript 3, so 1 times 3, I'm going to add these all together. And then iodine is in group 17, it has 7 valence electrons. So to get my total number of valence electrons, I do 4 plus 1 times 3, which is 3, plus 7, that gives me 14 valence electrons. I like to write that right up here, 14 electrons, so that I know how many I have to use. Step 2 says determine the central atom. If there's a carbon, it's going to be the central atom. There is a carbon in this one right here, so that is my central atom, and so I put a carbon. Also remember, hydrogen is never the central atom. The step 3 says arrange all the atoms around other atoms around the central atom. So I have 3 hydrogens, so I'm going to put them symmetrically around this. And then I have an iodine, and it really doesn't matter which position you put the iodine in, as long as you have 3 hydrogens and an iodine. And then it says connect to the central atom with single bonds. I'm going to show you what single bonds look like. I draw my single bonds as dashed lines. That dashed line represents a shared pair of electrons. I have seen it like this several times before also, with a dot dot in between. That dot dot is a shared pair of electrons. And so if you wanted to do it that way, I'm okay with that. But I will be drawing mine with the dash line, which is, and if you want to think about it as a pair of electrons like this being shared between them, that's just fine. Step 4 says fill the outer atoms with pairs of electrons until each has a full octet except for hydrogen, and count the total number used. So far, I'm going to count the total number that we used. I'm going to do it in white. Here are 2 electrons because it's a shared pair. There's another 2, so that's 4 total. Another 2, that's 6. That's 8 out of my 14 that I have to use. So I've used up 8. Now I've got to fill in the outer atoms. Remember, the outer atoms are these ones on the outside, but hydrogen is stable when it has 2 electrons touching it, and both of those electrons are counting for hydrogen. So I don't want to put any more electrons around hydrogen. It's stable because each of these have 2 valence electrons around them. But the iodine only has 2, and it needs 8. And so what I'm going to do is put pairs of electrons dots around them until I get to either 8 around the iodine or 14 total. My total so far now is 2, 4, 6, 8, 10, and so I have 4 more to go. Dot dot here and a dot dot there. Here a dot. Anyways, now if we look around that iodine, the iodine has 2, 4, 6, 8 because these count as a shared pair for the iodine. 8 electrons around it. Step 5 says place any remaining electrons on the central atom. The trouble is we don't have any remaining electrons. We use all 14 of them right here that we had. Once we get to 14, we can't put any more in there. And then step 6 says count all the octets. If all the elements do not have a full octet, then we need to share. If we look around here, this carbon in the center has 2, 4, 6, 8. You might say, well, that's sharing with those. I know, but they're sharing. And so that has 8 around it. This has 8 around it, and each of these have 2. We've just drawn our first Lewis dot structure for a covalent compound. Well, you might feel very confident now that you can do this without using the steps, but I'm telling you, you have to look at the steps each time. So we're going to do this one together. This is IBR, and each of these have 7 valence electrons. So if we look at our total valence, this also has 14 valence electrons. And we really don't have a central atom here because there's only 2 of them. So I'm just going to put I and BR, connect them with single bonds. And I am going to do the most electronegative first. And so the most electronegative element between these two is bromine. And so I'm going to start filling that in with dot dots until it has 8 around it now. And I've used this total of 8 valence electrons. So I have 6 more to go. And so if I go over now to this iodine and start to fill that in, each of these have 8 around them because they're sharing this pair that's in the center, and that's 14 valence electrons total that we've used. And that one's done also because we're out of electrons and everything is stable. For CS2, carbon has 4 valence electrons, and so I'm going to put my little 4 right here just as I'm adding them up. Sulfur has 6 valence electrons, but there are 2 of them, so that would mean 12 total. This is 16 electrons. I like to put them right up there. Carbon is my central atom, so I'm going to arrange my sulfurs around there and connect them with single bonds. And then the next step says to put electron dots or dots around the outer atoms until their octets are full. And so I'm going to start filling these in. I'm going to count though as I do it. This was 2 starting out and 4. This is now 6, 8, 10. That makes that one full. And then 12, 14, 16. That makes that sulfur full there. But and I'm out of electrons now. Now, the biggest problem is students stop right here because they don't go back and count all the octets. This carbon right here in the center only has around it 2, 4. It needs 8 total. You cannot just put dots on these because we're out of electrons. So what we have to do is go to step number 6, which says that if all the octets are not full and you're out of electrons, then you need to share electrons. I'm going to show you how we do that right now. I'm going to do this in white. I'm going to steal a pair of electrons over here and I'm going to share that in between. That's a double bond now. It looks like an equal sign, and so I didn't add more electrons, I just shared them in between there. Now this sulfur is still full. If you look around it, it has 2, 4, and then this is a shared pair, 6, and this is a shared pair, that's 8. This sulfur is still full, but that carbon only has 6 around it still. So you can make a choice. You could either steal a pair from over here and make another double bond, or you can steal another pair here and make a triple bond. Either way ends up being fine, and there's not really a wrong answer in that. Now everything is full. I've used up all my electrons, and that's what CS2 molecular structure looks like. SF2 has 20 valence electrons. I've just added them up to save time here. And so sulfur is going to be my central atom. I have 2 fluorines, which I'm going to arrange around there. Connect with single bonds. I know what I'm doing. That's why I'm moving really fast here. But you can see that I'm following all the steps. And then that's 4 electrons I've used so far. There's 6, 8, 10. Now that fluorine is full. It has 8 around it. And then there's 12, 14, 16. That fluorine is full, so I can't put any more around that. Now the next step says if there are any remaining electrons, which we do, we have 4 remaining electrons, they go on the central atom. And so they would just be dot dots on the central atom. There's 18 total, and there's 20 total. And so now I have, if I count my octets, each of these have 8 valence electrons around them, and so I'm done. One last example is an ion. This is a polyatomic ion, and normally if we added up the valence electrons on this, then we would see that this SO3 would have 24 valence electrons, but this -2 charge means that it's gained 2 extra electrons. So this has 26 electrons, and there is a way that we can show that. Sulfur is going to be our central atom, so I'm going to put sulfur, and I'm going to put oxygens around it. 3 oxygens, connect those with single bonds. That's 6 electrons so far. I put dots on the outside, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then I've got 2 extra ones. Those will go right in the central. And so you can see that all of the octets are full now. Each one has 8 around it, but we still have to account for these 2 electrons that were gained. And so the way we do that is we put brackets around this whole thing, and we put -2 or a 2- charge on the outside for the ions. Well, here are 3 for you to try on your own now. Make sure you follow the steps. I know I went through all those other ones fast, but you can always go back and take a look at them. And if you follow the steps, you should have no problem at least getting most of these correct. All right, have a good day.